Hello students, welcome back. Welcome back to the world of RoboMate. So students, we have been discussing the chapter circular motion. Now, let us start with the next module of the chapter circular motion. In this module, yes, we are going to discuss the concept of conical pendulum. You have heard simple pendulum. What is this conical pendulum? You want to know about it? Okay. Can I start the module? Alright, let me start the module. Conical pendulum. What is a conical pendulum? The students, conical pendulum is a simple pendulum. You all know what is a simple pendulum. Yes, a simple pendulum. It contains a bob attached to a string, and this string is fixed to a fixed support. Alright, so conical pendulum is a simple pendulum which is given such a motion. What kind of motion? The bob of the simple pendulum will describe a horizontal circle. Alright, the bob will describe a horizontal circle and the string will describe a cone. So how it will look? It will look like this. The bob of the simple pendulum performs, it describes a horizontal circle. That means it performs a circular motion, and the string of the simple pendulum will perform a cone. Such a pendulum is called as conical pendulum. Isn't it that easy? It's not that difficult. So easy. Is that clear? So this is the definition of conical pendulum. Now students, what we are going to do is, we are going to derive an expression for the linear velocity of the bob of the conical pendulum, and we are going to derive an expression for the angular velocity of the bob of the conical pendulum. Why? Because you see that bob is performing a circular motion. Is that clear? So can we move on? Alright. Now for this, let me bring back the conical pendulum. Theta. What is theta? Theta is the angle made by the conical pendulum with the vertical. Alright, theta is the angle made by the pendulum with the vertical. Now let h be the axial height of the pendulum. Alright, r be the radius of the horizontal circle described by the bob, and let l be the length of the pendulum. Is that clear? I'm going to consider all these things. Now, m is the mass of the bob. Alright, now what we are going to do, we have to derive an expression for linear velocity and angular velocity of the bob of the conical pendulum. Now first, let me draw the free body diagram. Free body diagram of the bob. What are the forces acting on the bob? Yes. Very good. The first force is weight of the bob, mg, will be acting downwards. Yes. Next, normal force. Normal force is a contact force. Where is normal force? String. What kind of force is there in the string? Yes, tension is there. Yes or no? Tension is there. So tension is a force that is acting in string. So here, R will be the force of tension acting on the string. Now you see here, R makes an angle theta with the vertical. So you can resolve R. Yes, R, the vertical component of tension is R cos theta. The horizontal component of tension is R sin theta. Any other forces? No. Now see here, this bob is performing a circular motion. Now students, for circular motion, what force is required? Very good, very good. For circular motion, you require centripetal force. So here, what provides the centripetal force? I'm asking you a question. What provides the necessary centripetal force? Yes, how this bob gets the centripetal force to move in a circle. See the diagram. See there. R sin theta. R sin theta is the horizontal component of tension. R sin theta is acting towards the center. So we can say R sin theta provides the necessary centripetal force. So then immediately we can write R sin theta is mv square by r. Also you see here, R cos theta and mg, they are balancing each other, yes or no? So we can write R cos theta is equal to mg. Now with these two equations, I can derive expression for linear velocity and angular velocity of the bob of the conical pendulum. See what I'm going to do. Let me carry this diagram forward and let me bring the equation. R sin theta is mv square by r. This is the first equation. R cos theta is equal to mg. This is my second equation. Now I'm going to divide both the equations. If I divide, what I will get? I'll get R sin theta upon R cos theta is mv square by r upon mg. You can cancel out r. You can cancel out m. Sin theta upon cos theta is tan theta. Tan theta is v square by rg. V square is rg tan theta. What is v? Yes, v is root of rg tan theta. So we have derived an expression for linear velocity. Now we have to find out an expression for angular velocity. Now students, we all know this. V is r omega. So instead of v, I can write r omega equals to root of rg tan theta. Root is disturbing me, so I will square on both sides. If I square, I'll get r square omega square is equal to rg tan theta. Tan theta is troubling me. Let me remove tan theta. See here, see this diagram. In this you have a right angle triangle. What is tan theta? Yes, tan theta is opposite side upon adjacent in this triangle. R is your opposite side, H is your adjacent. So tan theta is R upon H. I can substitute it there. What I will get? I will get R square omega square is equal to RG into R upon H. Now you see there. R square, R and R will get cancelled. So what you will get? Omega square is equal to G upon H. What is omega? Omega is root of G upon H. This is the expression for angular velocity of the bob of the conical pendulum. Isn't it very simple? Just with the free body diagram, I can get these two derivations. Is that clear? So students, these are all very simple. I am very sure you can do it. Alright? So time for me to go. I'll catch you with the next module. Until then, rise and shine.